Om Shri Sai Ram. Welcome to the second session of this chapter, Motion in a Straight Line. In this chapter, we will be discussing about the concepts distance, displacement, speed and velocity. So, let's get started. Rectilinear motion. So, what is this rectilinear motion? We have not yet introduced this some rectilinear motion. We have just introduced that we will be talking about the motion in a straight line, right? What is this rectilinear motion? Let us divide this rectilinear into two parts. One as recti and linear. What this stands for? This recti stands for straight. And what is linear? Linear stands for line or the gradual progression in a sequential manner. So that is none other than line. So what is that line? That should be a straight line. So rectilinear motion tells you the motion along a straight line. So that is what we were discussing. So we gave one more word which is rectilinear motion. So the example is motion of a car on a road. We have already seen it. So how the car is moving? It is moving along a straight line on a road, right? So now let us see the properties of rectilinear motion. Rectilinear motion need not be one-dimensional necessarily. In the last class, at the end of the session, we have discussed the motion along a straight line is one-dimensional. But here we are saying rectilinear motion need not be one-dimensional, right? So why? As per our definition, rectilinear motion can be any straight line in any direction. Motion in a straight line means the object should be increasing in a sequential manner in a straight line, right? So if that feature satisfies, if that condition satisfies, so it should be rectilinear motion, right? Rectilinear motion need not be one dimensional, but it is always possible that rectilinear motion be treated as one-dimensional motion. So that rectilinear motion which you are saying need not be one-dimensional can be always treated as one-dimensional. And how is that? Let us see. You have a coordinate axis. Now you have a car moving. So let us see how the car is moving. So let us see once more. As you can track down the movement of the car when I start the cursor, see the car started from here and reached here. So the y coordinate is also changing with respect to x coordinate. So if that is the case, it is nothing but two-dimensional motion, right? Because to locate a point in the space, to locate the point of a car when it is moving, you need 2 points, y and x, right? See, it started from here, it came like this in a straight line. So at every point you have x value and y value. Now to make our job easy, what shall we do? We shall rotate the axis in such a way that the motion of the car is parallel to one of the coordinate axes. Let us see. See, I rotated this axis. So now my motion of the car is just one-dimensional, right? Only the x values are changing as the car is moving. So the y value is always 0 on the x-axis, right? So we can always translate this straight rectilinear motion into one-dimensional motion by rotating the axis. Does this rectilinear motion change when I rotate the axis? No. Rotation of the coordinate system does not change the rectilinear motion of the car. The car still moves in a straight line. But the only difference which I made is I just tilted the axis to make our job easy. Alright? So having studied about the motion, let us now discuss about the parameters of the motion, right? On what factors does the motion depend on, right? So let us see the two words, path length and displacement. So let us know about what is path length. So path length is nothing but the total distance traveled. The total distance traveled by an object from initial position to the final position. Okay. So path length is nothing but it is the length traveled by an object. Alright. So if it starts from some point and goes to some other point, let us say initial position to final position, it may take any number of turns. It may travel many number of turns. But we were discussing about the length of that path it took. So if you measure the length of that path, it gives your path length. So from where to where? From a starting point to a final point. If you measure the length of the path taken by the object, that becomes your path length. So the second thing, the displacement. Displacement is nothing but the shortest distance between initial and final position. So how these two differ? Displacement is nothing but, you can also tell as change in position with respect to original position. So displacement can also be said as it is a change in position with respect to original position in a given direction. Okay, you are here from A, you went to point B. So if your friend asked, when you came here, if your friend asked, what's your displacement? Where is your home? If your friend asked you, so you will always point towards this direction. You cannot say my home is, for example, 30 kilometers away from the point B, from here. So 30 kilometers can be in any direction. So you need to specify the direction. So from here to here you are displaced. So I have been displaced from point A to point B in this direction. Okay, here the direction becomes important. That is the reason it is vector quantity. And as the path length does not depend on the direction, as long as you are traveling, the path length is there. You have a length. So it is a scalar quantity. So to be a vector, you need to have a magnitude and direction, and also it should follow the law of addition of vectors. So these are the three conditions to be a vector. Now let us see these two concepts with a small example. This is the initial point. You are starting from the home, this is the college, and this is a restaurant. So there are three places. For example, you started from your home, you went to college, you traveled some distance, and then you change your mind. After college, you started from the college to grab some food, you went to restaurant. So what is the length of the path you took? First of all, you went from here to here. Some length you have traveled, and from college you took path and came here. Some more length you have traveled. What is the path length? Path length is the total distance traveled. So distance, let it be d of hc. Let us, between house and college, let it be distance between college and restaurant be, not this, cr. dcr be the distance between the restaurant and college, and the dhc can be the path length between home and college. I am interchanging the words of path length and distance. It is both are same. distance is nothing but the length of the path, it vice versa. So you have traveled from home to restaurant, so you have traveled this much distance. Now if a friend, the same example which I quoted earlier, if your friend came and asked you, where is your home? Will you go back and trace back to say where my home is? No, we'll just say my home is here in this direction. Right? Your initial position is this. Final position is restaurant. So you will see, okay, this is my home. My home is towards north, this many kilometers, something. So this is the displacement. How much displacement you have from home to restaurant, how much change of position you took. So path length is nothing but DHC plus DCR. So these two, when you add these two together, you will get the path length of the path. Displacement is nothing but the distance between these two. Distance between these two is HR, let it be HR. DHR. Alright, this is how we define path length and displacement. So having known this, let us see the various cases of this. So this is your initial position, that is your final position from home to college. Alright, now you started, this is your initial, and you went and stopped there. That is your final position. In this case, what is your path length? Path length is the distance traveled. Already we know the distance between the house and the college is DHC. So this is your path length. So what is your displacement? Displacement will also be the same in this case. Right? If the change in position is from house to college. So how you will know the change in position? Just draw a line between them. The shortest distance will be your displacement. So in this case, what happens? Path length equals displacement in this case. Alright, let us see one more case. Again, initial position, that is final position. Now you started from your house, went to your college. After college, you came back again to your house. Alright, now how much length you have traveled? You have traveled some length, right? You went from house to college, from college to house. You have traveled some length. So it will not be zero. Some length you have traveled. But the displacement, you are sitting in your house. You just came back to your house. Before going, your mom saw you are in the house. After some time, again your mom said that you are in the house. By the time you went to school and came back. Okay. As long as your mom is concerned, you didn't go to school. Because you have not changed your position. Your initial position and final position are there itself. You have not gone anywhere. So basically what I am trying to say is, you are not displaced. You are in the same place as your initial position. By definition, we can easily say that initial position is same, hence the displacement is zero. But you need to know what I am trying to say. Okay. So here the displacement is zero, but the path length, but the distance is not zero. Because you are traveling. Distance is nothing but the travel you make. Displacement is nothing but the change in position. Alright. So here path length is twice of this distance and displacement is equal to 0. Now let us see one more. We have done all the cases. So we'll deduce from our observation. The magnitude of the displacement may or may not be equal to the path length traveled by the object. That is equal, right? That is what we have seen in the last 3 examples. In the second example only, in the second case only, where we have come across the displacement and distance are equal, because you are starting from your house and the final position is college. So there the distance and displacements are equal. But in the first case, in the last case, In the one of the cases, displacement is 0. In the other case, displacement is less than what? Distance. Right? So from there we can see that the value of the displacement may or may not be equal to the path length of the object. In the second case, we have seen that the magnitude of the displacement for a complete motion, in the sense, in the third case, we have seen the magnitude of displacement for a complete motion. You started from one point and came back to the same point, that is termed as a complete motion. For a complete motion, you can say there is no displacement because initial position is equal to the final position. You are at the same point where you have started. So displacement is 0, but you have traveled some distance. You went somewhere and came back. So there the path length is not 0. So these two are the deductions we have made from our observation. And third, therefore, the magnitude of the distance covered by an object is always greater than or equal to the object displaced. Yes or no? Right? The minimum possibility is where the distance is equal to the displacement. In all the other cases, you will have the distance greater than displacement. By definition only, you can say displacement is the shortest distance between the 2 points, between initial position and the final position. So that itself says magnitude of the distance covered by an object is always greater than or equal, in some cases, equal to the object displaced, which is called as displacement. Here you can think of one more thing. Can the distance be negative? Hold on and think. Can the distance be negative? No, because it is the length of a path. Length cannot be negative, right? So distance cannot be negative. But can the displacement be negative? Yes, displacement be negative. It is the relative position of the object with respect to its original position. If my original position is here, I may move right, I may move left. If I move right of 5 meters, I have to differentiate to that point with the same value 5 meters if I move towards my left. If I only say 5 meters, it doesn't make any sense. I need to say I am moving 5 meters. I changed my position with respect to my original position towards right or towards left when you are talking about your change in position. So displacement can take the negative values, but distance cannot take the negative values. It can be 0, it can be positive. 0 is not that important. If you take the distance from one point to the same point, that means you have not traveled anywhere. There the distance is 0, right? So having known the distance and displacement, now let us see one more type of motion which we call as the uniform motion. And what is uniform motion? The uniform motion is if an object is moving along a straight line. If an object is moving along a straight line, covers equal distance in equal intervals of time, however small the time interval may be, it is said to be in uniform motion along the straight line. Okay, uniform motion along the straight line. What it says, you can see in the picture. See, a school van is covering a distance of 10 meters per each second. So as the time is increasing gradually, second by second, the distance is increasing by 10 meters. So for every 1 second, it is covering equal magnitude of length, right? So equal magnitude of time, equal magnitude of length. So 1 second, again it is covering 10 meters. For next second, again it is covering 10 meters. Such type of motion, if an object is moving in this fashion, we call this object is in uniform motion along the straight line. So because then object is moving in a straight line. In this chapter, we are only talking about the motion in a straight line, right? So this is about the uniform motion. So think about this, 1 second and 10 meters. Here also 1 second and 10 meters. So if you relate these two, time and distance, you will get one more quantity. What is that quantity? So let us relate the time and distance now. What do we get? We get speed. Speed is the rate at which an object covers distance. Alright. So what is basically it is saying is the rate at which you are traveling. You are traveling some distance. So at what rate you are traveling, that gives you the speed. Speed is nothing but it is a scalar quantity. What is scalar quantity? It has magnitude, no direction. As a distance has no direction, it only takes the values as it increases the length of the path. So what happens? Speed also does not have any does not have any direction. All right. So speed is equal to the path length. This length of the path by time taken. When you come across the rate, you can always say it is with respect to time. Rate at which an object covers the distance, that means at what rate it is covering the distance with respect to time. Alright. So now with respect to path length we have related to time. Now let us relate displacement with respect to time. That term we call as velocity. Rate at which an object changes its position in a given direction. So how the object is changing its position in a given direction, right? Here you can see you need to know this object changes its position. This is important because when you change the position, you need to bring this direction, right? So to have a velocity, the one who is running should make sure that he is moving in such a way that he is moving away from his initial position, right? That is displacement. And at what rate he is moving away from his original position, that you call as a velocity. All right. Here velocity is a vector quantity because displacement is a vector quantity. And if you are changing your position, in what direction you are changing in position, at what rate you are changing that position, that gives you the velocity. So velocity is displacement by time taken. All right. So displacement is a vector quantity. Here the velocity can be 0, right? You go to some other point and come back, so the displacement is 0. But speed is what? You came back and forth, you traveled something, but this speed cannot be 0 there. All right. So both SI units of both are meter per second. Why? Speed is nothing but path length. Length will be denoted by meters. The units of the length is meters, and that time is seconds. So you can go the SI units are, you can give the SI units a meter per second. Here displacement is also nothing but some distance, right? Shortest distance. So it is also meter second. So SI units are meter per second. All right. So let us see with an example now. The same example, you started from your initial position, you went to your final position, and you came back to your initial position. Just now we have discussed. So let us give some values. During the total journey, DHC means the distance between the initial position and final position is 2 kilometers. Your time given is 1 hour. Hence, the path length is the distance travelled from initial to final and then final to initial. So it will be twice the length. So it will be what? 2 plus 2, that will be 4, because he is going 2 kilometers and also coming back 2 kilometers. So total length, total distance traveled is 4 kilometers. So displacement, how much, what is the change of his position? He started here, ended here, displacement is 0. So you know path length, you know displacement, you also know the time he took to complete the whole journey is 1 hour. So now we can calculate the speed and velocity, right? So let us see. Speed is path length by time taken, as you know, it is 4 is the total distance traveled, 1 is the total time taken, 4 km per hour, that is your speed. Alright, now velocity, displacement by time, displacement is 0 because he started at house, ended in the house, 0 by 0, it is velocity is 0 km per hour. That means he is not changing the position as the time progressed. We are taking the time interval of 1 hour. If you take the time interval of 1 hour, after 1 hour you see the object is at the same position. So velocity is 0. So we got familiar with the terms of speed and velocity. Let us study a beautiful concept, graphs. Why do we use graphs? Graphs saves time. Instead of writing a whole question and telling you the object starts from somewhere and reach somewhere, it has some velocity. So this all information can be clubbed and represented as a graph. I guess you have already studied linear equations in your earlier classes. So what is this? This is a straight line, right? So what is the equation of a straight line? You already know. Equation of a straight line, the generalized equation of a straight line is y equal to mx plus c. And this we call as a horizontal axis, this called a vertical axis. In the horizontal axis, we have time. That means you have a different points of time in the horizontal axis. In the vertical axis, you have a distance. As the time is progressing, for the different points of time, you have the different distances traveled by the object. At this point, after 1 hour, the object covered this much distance. After 2 hours, that it may travel this much distance. So it is the plot between the distance and time. So for every line there will be a slope, right? So what the slope gives you here? The slope of the distance time graphs gives you speed. How? Let us find out. You have this distance time graph. This is the same as in the previous slide. You know this equation of straight line is y equal to mx plus c. What this m stands for? What this c stands for? M is nothing but the slope of the line, right? Now, see this graph. If you see this graph, you can know that at x equal to 0, what is the y value? At x equal to 0, what is the y value? X equal to 0, the y value is also 0 here, right? So if you put if you plug into this equation for x equal to 0, what it gives? Y equal to c, right? So from the graph, you know at x equal to 0, y is also equal to 0. So the c becomes 0 at c becomes 0, right? So what does this c tell you? What does actually this c tell you in this equation? C is telling you the y-intercept, where the line is cutting the y-axis. The line is cutting the y-axis at 0. At 0, right? So line is cutting the y-axis at 0. That we call as a y-intercept. Now m is a slope. So what is slope now? Slope is nothing but the gradient between the 2 points, right? The slope is, what do you mean by slope? Slope is nothing but the rise over run. This is the informal definition. So along the time you are moving forward, okay, the distance is also increasing. So how much rise I am getting if I am moving forward? There is a hill. You are going up the hill. If you went here, if you are at this point, if you started from here, point A, if you went here, what does that mean? It is equivalent to saying that you went forward some distance, went forward in time, and you have climbed it. So this is equivalent to this, right? That means how much rise you are making. This is the rise with respect to run. With respect to this much run, how much rise you are making. That is what the slope gives you. If this is so steep, what happens? You are making so much rise for this run. Between these 2 points, let us suppose this is A, this is B. This is run again, this is rise. Now the rise is even more for the same run. So here the slope is more. So this is what the slope gives you, right, for the normal graph. Now let us compare this to distance and time graph. Distance and time graph. So what it gives? Distance, the slope gives y by x. Actually, to be precise, it should be delta y by delta x. Delta is nothing but the difference in y, difference in this value. This is the rise, right? If you have the coordinate axis like this, it started from some point y1, it ended some point y2, it started some point x1, it ended at point x2, right? So how much rise you have made? The rise, you can always tell the rise when you have 2 points, right? For with 1 point you cannot say you have a rise. You need to have 2 points to find a slope. So this should be delta y by delta x. Now why it is written as y by x? Because you know the c equal to 0. As c is 0, y minus 0 by x minus 0 gives you y by x. So this gives you the slope. This y by x ratio, this comparison between y axis and x axis with respect to x, how much y is changing, that can be also seen in another quantity. How? If this line is making some theta, angle theta with the horizontal axis, what does the tan theta will give you? What is this? This is nothing but delta y, or y, because it is starting from 0, and this is what x value. We can write as delta x to be precise. So tan theta will give you what? Delta y by delta x. Tan theta will be equal to delta y by delta x. So this delta y by delta x in our case will be y by x, because c is 0 there. So y by x, I can also written y by x as tan theta. Tan theta. So my slope of the graph can be also given as tan theta. So m is equal to y by x, that is equal to distance by time. So what the y axis represent here? Y axis is the distance, x axis is the time. So how much distance I am traveling with respect to time? As I am moving forward, as the time is changing, how much distance I am covering? That is the relation between the distance and time which the slope gives you, and this term we call as a speed. Alright, so here you can say, sir, here you have taken the c as 0. For example, if I take the c as some value, c is nothing but the y-intercept. For example, if I take the same straight line starting, has the y-intercept at 2, okay. Suppose it's straight line, okay. It's straight line. Does it make any difference to the slope? What does this mean? It starts at 2. That means at t equal to 0, the particle is at a distance of, for example, if this is in meters, it is at 2 meters. Distance of 2 meters. It is already at the distance of 2 meters when the t is equal to 0. Right? Now see the angle with this, see the angle which this straight line, this new straight line is making with the horizontal. Take a parallel line with the x-axis. See this. This also will be equal to theta. So for different values of c, the slope does not change. The slope does not, that means, so the speed is never affected by the initial point. Speed is only affected by how once it starts moving, how it is moving with respect to time. That is only the value. What will be the slope here? It will be nothing but y equal to mx plus c. To find the value of c, what happens? The c becomes 2 there. C becomes 2 because at x equal to 0, c is 2, y value is 2. At x equal to 0, y value is 2. So, to find out the slope, it becomes y minus 2 by x. X minus 0, because corresponding to 2, when the y value is at 2, x is at 0, t is at 0. So, time is 0 and at the time equal to 0, it is at 2. The distance is already 2. So these are the corresponding. Why I am seeing this? This is the very important to know the slopes. Why you are using the slopes? To draw a relation between these two quantities, distance and time. When you draw the relation between these two quantities, everything will be easy. Alright. Now we have learned about distance and time graph. Now next we will see about this position with respect to time. So as we studied, this slope will give you speed because it is a distance time graph. Distance by time will give you speed. The second one, position time graph, case 1. Let us see. You have a position, you have a time. Now the particle is moving, for example, this is A, this is B. So it moved from A to B. The coordinates are given. So this is 2. This is also 2. So it took 2 hours to change its position in the positive direction from 0 to 2 kilometers. In 2 hours, it is raising 2 kilometers. That is what it is depicted. After that, what happened, you can see. From next 2 hours, after 2 hours, from 2 to 4, what happened? It changed its position from 2 to 0. X is 0 on this axis, right? Sorry, y is 0 on this axis, right? So the position again becomes 0. Position started from 0 and became 2, and after the next 2 hours, it came back again. This is what we have discussed in the earlier example. When you started from house to college and then from college to your house. That is what represented pictorially in the graph. So 2 kilometers, in the same 2 kilometers, you have come down, and it took 2 hours to come from your B to, for example, this is actually point A only. Let us give another coordinate C, because the time is changing. So let us write these coordinates 0, 0, 2, 2, 40. Alright. Now what is the slope of this position time graph will give you? The slope of this position time graph will give you the velocity. It is the changing of position with respect to time, right? The slope of position time graph will give you the velocity, what we have already studied. Now, as we have given, let us give this 0, 0, 2, 2, 4, 2. Is the slope constant overall? Is the slope constant overall? No, because here if you see, it is making angle theta 1. Now when it is coming down, this is the slope. It should be always taken with respect to the positive x-axis. If you take this as angle, inside angle as theta 2, so the remaining angle will be 180 minus theta 2. Right? To get the overall slope, we need to add these two slopes because these are not equal throughout the time. From 0 to 4 hours, the slope is not equal. From 0 to 2, it is in one direction. From 2 to 4, it is in the other direction. So you cannot take the slope by integrating. Okay, let us not go to integrating. Let us see by parts. Basically, you can say it starts from 0 and ended at 0. The position is 0 starting point and then ended at 0. You can say the velocity should be 0. Right? This is our basic intuition seeing the graph. Now let us prove it. So slope will be slope of 1 plus slope of 2. This is slope of 1. This is slope 2. So what is slope 1? Slope 1 is tan theta 1. You already know this is tan theta 1. Slope 1 is tan theta 1. This is the rise. This is the run. So this is tan theta 1. So tan theta 1 is what? Y by x. So what is y here? 2. What is x? 2. 2 minus 0 by 2 minus 0 is what? Because with respect to this we need to take. So this is 2 km by 2 hour, that is 1 km per hour. Now slope of tan theta 2, this slope, if you find out, the slope is nothing but, for this line, I am talking for this line, slope is nothing but tan of 180 minus theta 2. What is tan of 180 minus theta 2? It is in the second quadrant. In second quadrant tan is negative. So it can be written as minus of tan theta 2. Right? So that is what? Slope of 2 is equal to minus of tan theta 2. So you can tell it is minus of y by x. So the same thing follows, minus 1 km per hour. In the first case, it is increasing 1 km per hour in the positive direction. In the second case, it is coming back original position towards its original position. That is why it is minus 1 km per hour. You add these two slopes, what you will get? You will get slope is 0 because one is 1, again another is minus 1. So overall change is 0. If I ask you within this interval what is velocity, I will say 1 km per hour. Within this interval what is the velocity? I can say minus 1 km per hour. 1 km per hour in the negative direction. So overall for 0 to 4 hours, what is the change in, what is the velocity, average velocity, if I ask you, that will be 0. Okay, I hope you understood this. Now let us go further and one more case. What happened here? You see, this is the time axis, this is the different points of time. So from 0 to 1 what is happening? Is there any graph? No. That means the body is not moving from 0 to 1. right? Body is at rest for 0 to 1. It starts moving from 1 hour. After 1 hour, it starts moving. And it is in uniform motion after that. Why I am saying uniform motion here? What is the meaning of uniform motion? It should travel equal distance in the equal interval of time. Equal distance with respect to time, that is nothing but the velocity, right? What is velocity? Meter per second. So some meters per second, if the velocity is constant, if the velocity is having a constant value, that means what? In our case, when we have studied the uniform motion, it is traveling 10 meters per 1 second. What is the velocity there? 10 meter per second, right? After each second, it is covering 10 meters. So the velocity is constant there, right? So in uniform motion, velocity will be constant. How do you know velocity will be constant from this graph? See, this is a straight line. What the slope of position time graph will give you? What the slope of position time graph will give you? It will give you velocity. Is the slope changing anywhere during the line? At any point? At any point you can take. At any point of time, is the slope changing? Draw the horizontal axis at every point. At every point, if you have a theta, this is also theta, this is also theta, this is also theta, with the horizontal. So at all the points, the slope is constant. That means velocity is constant. If the velocity is constant, you will have the uniform motion. So from here you can also say what is non-uniform motion. Non-uniform motion is nothing but when the body is not satisfying uniform motion, that we can call as non-uniform motion. To be precise, you can also say that if an object is covering unequal distance traveled with the equal intervals of time. For example, in 1 second, in the first second if you travel 10 meters and second if you are traveling 9 meters or 8 meters or any other thing which is other than 10 meters, that means what? You are changing your velocity. So when the velocity is changed, that is called as non-uniform motion. Uniform motion, you have a constant velocity. In non-uniform motion, you will have a variable velocity. The velocity will not be constant, it will keep on changing. It will slow down or speed up, something. So this is what we have. So interpretation from the different, again one more interpretation, case 4, which I have discussed now. Here you can see in this graph, this is how the body object is changing its position with respect to time. For the interval between 0 and 1, you can see there is a constant slope. There is a constant slope. The angle is constant at every value. So from 0 to 1, you can say it is in uniform motion because the slope is constant. When the slope is constant, the velocity is constant. As you move after 1 hour, you can see there is a slight increase in the position. For example, if I magnify this, it was going in such a manner. As the time is increasing, it is slowly increasing, shifting its position. This is the position, this is time. So as the time is increasing, the position is gradually increasing with the slow and steady equal rate. Now after this point 1, what happened? There is a slight increase like this, a slight increase in the slope. That means now there is a slight increase in the rise with respect to the run. That means with the increment in time, you will see a slight increase in change in position. Previously, the change in position may be, for example, 2 kilometers for 1 hour. After 1 hour, you can see there is slight, it may increase to 1.2 kilometers. The change in position may be 1.2 kilometers per 1 hour. So the rise is little bit more. So this is called as a non-uniform motion. So is it constant here? Is it constant here? It keeps on changing its slope. It keeps on changing its slope like this. At this point, you can see for the small change in time, you can see how much change in velocity. There is a huge change in velocity. This much change in velocity in 1 hour. For the same change, you can see this is the change in velocity for 1 hour in this region. So the velocity here, the change in position with respect to time here is less. The change in position with respect to time is more here. The velocity is keeping on changing here at every point. At here, at every point the velocity is keeping on changing. That means it is non-uniform motion after 1 hour. Towards the end, so first is 0 to 1 hours uniform motion, second after 1 hours it is non-uniform motion, and the third towards the end at rest. You can see after 4 hours it is almost flat. That means if you join, for example, this is 4 kilometers. So after 4 hours it is at 4 kilometers. If you take 5 hours, still it is at 4 kilometers. 6 hours, still it is at 4 kilometers. That means it is not moving. When it is not moving, what we call as, it is called as rest. So no motion. Understood? So in the same graph we have uniform motion in the first part of the motion, in the earlier part of its motion. After 1 hour it is going to non-uniform motion. Towards the end it is having no motion. Right? Now we have an example. The position time graph of two bodies A and B are shown in the figure. Which of these have the greater velocity? This is the figure we have. What will have the greater velocity? Velocity is nothing but the slope. How much change in position with respect to time. By seeing this, you can see the A's increment is more. Take this time period here. For example, take much more larger. For example, take this time period here. So from 0 to here, in this much time, what is the change in position of B? Is this. For this much period of time, what is the change in position of A? This. Let us suppose this is x1, this is x2. Which is more? x2 is more or x1 is more? Of course x2 is more. x2 is greater than x1. Which means the velocity of A is more. Right? Because for the same increment of time, you have more increment in change of position for A. How can you write that? The more increment means what? More slope. More slope with respect to the time. Right? So this angle, let it be theta 1. Let it solution. This is theta 2. Let it be theta 1. So which angle is more? Theta 1 is more than theta 2. So body A has a greater velocity. So this is what about the position time graph. Let us solve two examples in this session. If I give you a graph, okay, this is this is 6, this is position, this is time, this is 6, this is in meters, this is in seconds, and this is 2, this is 4, and this is 6. This is 6. So tell me the region. This is A, this is B, this is C, this is D. Tell me the region where the velocities are positive, where the velocities are negative, and where it is constant. Where it is constant. Where the velocity is positive, where the velocity is negative, and where it is constant. Pause the video. I have given you the values. This is 4, this is 2, this is 6, and this is 6. I hope you have already solved it. Let us see the velocity here for the segment AB. So what is the change in position? Here the coordinate is 0, 0. Here what is the coordinate here? Coordinate is 2, 6. So the slope for AB is 6 by 2. That is nothing but 3 meter per second. So 3 meter per second positive. So in the segment AB, velocity is positive. I hope you can see this. Let us see for the segment BC. What is the segment BC here? It is nothing but the same value of y, and you have increased the time from 2 to 4 seconds. So let us see the slope of this BC. BC is equal to 6 minus 6 by what? 4 minus 2. This gives you 0 by 2, which gives you 0 meter per second. By seeing the graph, you can see it is not moving. As the time is increasing, the position is not changing. It is not moving up or moving down. So at BC, in the segment BC, the velocity in the region of BC, the velocity is 0. Now, if I take this region CD, what is the final position here? What is this thing? It is 6, 0. Now what is the slope between these 2 points? Y2 minus Y1, because this becomes Y1. This is the initial point, this is the final point, it becomes. So slope between these two is 0 minus 6 by what? 0 minus 6 by, this is 2, okay, 4 and 6, yes. This is 6 minus 4, that is what? Minus 6 by 2, that gives you minus 3 meter per second. The slope is negative. The slope is negative in the section VCD. VCD slope is negative. It is coming towards its original position. So this is how you can see where in what region velocity is positive, in what region velocity is negative, in what region velocity is 0. It is not changing its position. So this is the basic example we solved today. I hope you enjoyed this session. In the next session, we will be seeing an interesting topic called relative velocity. What does that mean? When you move, what happens? You are in the motion. What you are observing will also change. When you rest, you can see if something is moving at 3 meter per second, you can see yes, he is moving 3 meter per second because I am at rest. If I am also moving with respect to that object, what happens? The relative distance between us will be changing because I am also moving, right? So how can we define that kind of motion? How can we define that velocity, right? We'll discuss this interesting topic in the next session. Until then, study and revise the topics we have studied in this lesson. Till then, thank you. Saira.